Hello ladies and gentlemen, welcome back to another video of the Artless Moth. Today we're going to be talking about, we're going to be doing a new series and we're going to be talking about fictional solar systems. Like say if like they find a new solar system, we can name it this or we can name it that. So these are going to be fictional solar systems. So today we're going to be talking about a fictional solar system called ZL-55392. This consists of a tiny red dwarf, 78.5 times as slow as Jupiter, and it contains, if I remember correctly, 3 rocky planets and 1 gas giant. So you're probably asking me, why call it ZL-55392? Because I thought it sounded cool. It sounds awesome. To me, of course. To you guys, you might think, well, sounds absolutely awful. But this is the weird thing. ZL-55392 is, well, it's just it's really small. It is a tiny star. It is just stupidly small. So the first planet we're going to look at is ZL-55392d. This planet is 2.68 times the mass of the Earth. It has a radius of 7,594. Temperature of minus 138 degrees. Even though it's in the hot zone. The reason why it has a temperature of minus 138 degrees is because it has an albedo. Now, these are just planets I've just added in. It has an albedo of nearly 1. Nearly 100% albedo. It has an albedo of 97%. Our planet Earth has an albedo of 33%. This planet reflects 97% of all light that hits it. So ZL-55D, as we're just going to call it, has an effective temperature of the same temperature as the surface temperature. It has a radioactive power of 1.27 petrawatts, I think that is. Yeah, that's kilowatts, megawatts, gigawatts, terawatts, petrawatts. Yeah. No atmosphere, but it has a very large core. This is where it becomes a bit confusing because, as I said before, these are planets I've just added in. Now, normally when we find an exoplanet with a very large core, for example Mercury, even though it's not an exoplanet, it has a very large core, we have to start to think, is it the core remains of a gas giant? And ZL-55392d, I think, looking at the iron content, it could be the remains of gas giant, but there is no ring around the star to show that it is the remains of a gas giant. Also, ZLD, it's a no, this is really weird because it has a surface temperature of minus 138 degrees, yet it has a desert. It's a global desert, as you can see. Now it's really odd. Now we're going to move on to ZL. Well, we're going to move on to this planet. And you can already notice it's got a green atmosphere. The reason why it's got a green atmosphere is because the amount of red light or infrared light coming off the red dwarf. It has a very comfortable temperature of 19.3 degrees Celsius. A little too warm for us, but it does suit us. It has an atmospheric pressure of 0.0557. That atmosphere is 0.000000550 atmospheres. Very sparse atmosphere. And also has an albedo of nothing. Effective temperature is -12 degrees. Greenhouse effect is 31.7 degrees Celsius. Scale height is 3.53 kilometers. It has a decent sized core. And also this planet is 2.86 times the mass of Earth. Radius is 8,476. It's a rotation period of 1.04 days. Unlike the quite long 138 long day on ZLD. ZLB is it can probably support human life if we're able to build an anti-gravity generator that's able to put the gravity up to 1G. Now, is an inclination of 2.72 degrees, and it has two small moons, ZL-55392BB and ZL-55392BC. BB is a cold moon. It's only 414 kilometers radius. And this moon has a very large iron core. So what this means is it probably used to be a larger moon that once got hit, and this is probably where both of these moons came from. BC is a bit different. Very tiny iron core, large silicon outer core, and a lot of water. Now you're probably wondering, how can a ice moon be so close to a star and yet not vaporize? Its albedo is slow also, but the ice acts like a reflective shield, reflecting that light off into space. And that's what keeps the moon cool. Now we move on to ZLC. This planet is the largest of the rocky planets. But there is something odd about this planet. As you can already see, it rotates on its side. This planet also has a moon that is on an elliptical orbit around it. This planet also, even though it is the largest in mass, it is not the largest in radius. It is basically an iron ball with a very thin silicon crust. What this means is this planet will be creating a very strong magnetic field. Also, it will create a very strong pull. And so, its moon, that is surprisingly 2.2 times the size of our moon. And it sounds like there's just been a collision. Oh yes, there has just been a collision. So what we're going to do is we're going to change its orbit just slightly. So this moon, it's lost mass. Yeah, I know it's lost mass. 2.25. So again, as I said, 2.25 times the mass of the moon. It's not a very stable temperature right now because it's got a rotation period of 335 days. That is a long, very long day. This planet has a day of 1 day, surprisingly. Surface temperature is minus 86.8 degrees Celsius. No atmosphere. Albedo is 0.53, so just over halfway. Now we come to ZL-E. I'm sorry for the commotion outside. ZL-E is a gas giant. It's 9.58 times the mass of the Earth. It's 37,864 kilometers in diameter, or radius. It has a surface temperature of minus 109 degrees Celsius. It has a rotation of 1 day. Again, very odd for a gas giant. It's 97.7% hydrogen, 2.34% silicon. It's an albedo of 0.31, and this is standard for a gas giant. It has an axis of 1.97 degrees. It has an inclination of 0.327. And it has an orbital period of 34.2 days. Now, it has a density of 252 kilograms per meter cubed. So this is a surprisingly heavy gas giant. If I remember correctly. Now, if I look at this, yes, it is a very, very light gas giant. Very light gas giant. Very. If I look at Saturn, yes, still very light. It's only 252. And this is odd for gas giant, for it to be so light, even though it's got a mass of 9 Earths. It should not be this light. And now we come to the star. A very dinky star. Its surface temperature is incredibly low, at an outstanding 2000 degrees Celsius. On here it says 1806 degrees Celsius. But on here it says 2079 degrees Celsius. Luminosity is 0.00122 suns. And that's odd. It has an age of 100 billion years. And this is also odd. Rotation period of 11.6 days. That makes it very active. Again, it shows here 1806 degrees Celsius. Density is quite high at a staggering 150,991 kilograms per meter cubed. Radius is 61,767. So this gas giant in this system is really half the radius of this star. So if we look at the activity on the star surface, we can see that it is very active. And if we look into this, you can see all these sunspots. Very active star. So, this has been the review of the ZL-55392 system. I hope that you enjoy the system, and next video I want you guys to think of the next realistic system of what you would like. Now, if you would like to see a complete rocky system, complete counter system, or mixture, just like our system, put it in the comments. Put your suggestions in the comments. I hope that you enjoy this video. It's the Arduous Moth, signing out. Bye.